Let's talk about algorithms. Well, what is an algorithm? In order to understand that, let's think a little bit about how you explain to a person how to do something. I'm sure you've had the experience of telling somebody how to do something and they come back and they do it and it wasn't what you had intended. Or at least they didn't do it in the right way, or at least how you were thinking about it. So there was some miscommunication, right? You were intending to tell somebody how to do something, and yet they didn't do what it is that you thought you told them. So what went wrong? Well, there's a few ways that things can go wrong. Maybe you assumed they had some knowledge that they didn't have. Or perhaps you specified something with some ambiguity and you didn't realize you were ambiguous, and so they misinterpreted what it is that you were saying. This can happen in lots of different ways. Let's look at a simple example. Suppose I want to tell my daughter how to make a peanut butter and jelly sandwich. Well, I might say, go get the peanut butter and jelly and bread and bring it to the counter, put on some peanut butter, put on some jelly, put it together, and you're done, right? I know a lot about making peanut butter and jelly sandwiches, and so that seems like perfectly sufficient instructions. But is it? Well, let's start with some ambiguity. Was there anything ambiguous about those instructions? Well, it depends a little bit on what's in the refrigerator. What if there's two kinds of peanut butter in the refrigerator? I said, get the peanut butter, but I didn't say get what kind of peanut butter. And suppose she picks one and it wasn't the one that I had intended. Well, she did what I said, but I wasn't clear enough about what I was saying, and so my instructions were ambiguous. What if I told her to do something that she didn't really know how to do? For example, I said, put some peanut butter and jelly on the bread, but I didn't say how to do that. Maybe she hadn't done that before and she saw this material, the peanut butter, that was kind of soft, so she got a spoon. And it turned out a spoon isn't a good tool for spreading peanut butter and jelly on bread, and so she didn't do as good a job as if she had picked a knife, which is what I had chosen. And the problem was that I didn't give enough information because I assumed that she knew something that she didn't know. So these two kinds of mistakes, ambiguity and specificity, are two fundamental challenges in explaining how to do something. And that's when I'm talking to a person and we have a lot of shared understanding and we can have some back and forth. Now instead, imagine that you're giving instructions to a computer where we don't have the same understanding, right? We don't speak the same language, and the computer can't ask me for clarification when it doesn't understand something. So when I want to tell a computer how to do something, I need to give it instructions in a way that are both unambiguous and specific enough so that it understands what it is that I want it to do. Furthermore, there's this basic issue of language. How do I tell the computer what to do? I can't just talk to it. It doesn't understand my language. I could go ahead and write the full instructions in programming code or computer language. In fact, when we actually want to program the computer to do it, that's what we're going to have to do. But suppose there's a middle ground. Suppose I want to communicate to another person what I want the computer to do. This is useful for situations where I want to tell somebody how they should direct the computer to solve a problem. Or maybe I want to tell them how I'm planning on solving the problem and I want the person's feedback. In that case, I might use something called pseudocode. Pseudocode is a written language, but it's not pure English and doesn't have all of the details of a computer formal language. It's somewhere in between, and this is commonly used to communicate between people, and even just for a single person to write something down when they're trying to figure out how something works. So this general idea of explaining how something works, or how something should work, that is unambiguous and specific enough, is typically called an algorithm. An algorithm, formally, is a set of rules that describes how to accomplish a task. Of course, to do it well, it needs to be unambiguous and specific.